Okay, awesome. So we're talking about the new WebSocket layer in Phoenix today. Just landed this weekend in Master, so you probably have not played with it yet. And basically the goal is, or the vision is, doing real-time stuff in your web app should be as simple and as straightforward as writing like a RESTful endpoint. So we built in some abstractions to make things like doing pub/sub and channels and something you would have otherwise done in like Socket.io and Node, if you're familiar with that. We built in kind of some similar mechanisms, but going a little bit step further and making it almost like a RESTful routing layer, but for WebSockets. So it should be almost as straightforward as routing HTTP requests to a controller action. We should be able to route socket messages about particular channels to a channel handler. So we're going to basically show this off just by building a chat app. And then maybe if we have a little bit of time, I'll go into some of the fault tolerance that I've built in to kind of get some ideas on the approach I took and whether or not it's a good way to go. But to get started, basically we'll use Phoenix's new task. So Phoenix has a basically project bootstrap task to get your project going. So if you clone Phoenix, you'll be able to run mixphoenix.new in the Phoenix directory. And we're going to create an app called Chatty. And we'll give it a location to live. This is basically just going to generate me a project hierarchy with all the necessary conventions set up in place. But you could roll your own mix app yourself and pull Phoenix in if you needed to. Oops. So if we go into that directory, Chatty, tree here, we can see Phoenix basically just seeded out a directory hierarchy. There's a config for configuration, different environments. It added a single pages controller, so we get like a hello world if we launch the app, and it gave us a router. And then it also pulled in a static directory with phoenix.js. And that's it's a very small JavaScript dependency for the WebSocket layer. So Phoenix.js is going to give you the channel pub/sub support on the client, and it's also going to multiplex a single WebSocket connection. So we can basically send multiple events and channels on a single connection, so we don't have to worry about starting multiple WebSocket connections because most browsers are limited to a certain number. So if you open this up and explore it, actually first, before we forget, we need to run deps.git and compile after we bootstrap our project. And then we open that up in Vim, see what it looks like. There we go. Still compiling. Should be about done here. Great. All right, so we can start this app up. This is basically a bare bones app. We haven't written any code yet, but Phoenix gives you a start task. So now we have our app running on port 4000. So if I fire that up, I get hello world. So we're running a Phoenix app, and we want to convert this hello world app into a chat application. So to do that, we need to do a couple things. One, we need more than just being able to render a hello world text to the screen. So we'll make like a static index HTML page now. So again, there's no view layer in Phoenix currently, but it should be in soon. I have a branch that has some experimental EX compiled templating, but at the moment there's no view layer. So this process should be a little bit more elegant pretty soon. Hopefully before Elixir Comp we'll have a better story. But for now, I'm just going to create a views file or views directory with an index HTML that we can render. And so you don't have to see me copy a bunch of HTML. I have already had it in a Vim buffer here. So this HTML you see here, it's nothing special. It's using Bootstrap, and it's just rendering input for a chat messages and as well as a username input, and that's it. So there's not a whole lot to it. The other thing we need is some CSS, so doesn't look like junk. So we'll create that. And then in our pages controller that Phoenix added to our project, instead of rendering text hello world, we actually need to render that file. So again, this will be a lot more elegant in the near future, but for now, we can just read that file directly. What's that?
You have a K in there, Chris.
What's that?
You have a K in the HTML?
I have a K.
Yeah.
Ah, tricky. Okay. So now we need to restart our server. There's code reloading in place, but just since we added new assets, I just want to make sure it's good to go. So theoretically, oh, this looked a lot more pretty on my non-shrunken resolution. So we have a username input, then beneath that, Bootstrap has collapsed our message that's off the screen that no one can see. It's not very nice. Oh, there we go. Okay. So I should be able to say my username is Chris, type a message, and it should show up in the white space. But this is just a static page that we've rendered with 2 containers. So we want to make this into a real-time chat app now. But to do that, we have to do a couple things. So Phoenix router, if anyone's not familiar, that Bootstrap task seeded out a router already for us. It added a static plug middleware, and then we have a single root GET request that rendered that index page. So what we need to do for a WebSocket layer support is use Phoenix router socket. So it's an optional opt-in layer. And what this is going to bring in is like a WebSocket handler for us, and we have to mount that at a particular location. So the way that WebSockets work is they send a GET request to the server, and then it's upgraded to a WebSocket connection. So that mount says what you want to serve as that GET request. That's going to have clients request an upgraded connection. And the only other piece of that is Phoenix has a concept of channels. So instead of dealing with straight WebSockets, we abstract a little bit. So channels can almost be thought of like if you have a controller for like HTTP requests. Channels are going to field WebSocket connections. So it's a place to group application behavior around a particular thing. So if I had like a user's controller, I could have a user's channel where I want to broadcast events about a particular user. So we'll use the channel DSL. So for a chat app, we're going to have a rooms channel. So if you're modeling your application, you're going to have many chat rooms. So it makes sense for me at least to have a rooms channel. And that's going to be handled by a channel that we define. So I can define chatty.channels rooms. So we haven't written that rooms channel yet, but it's going to only be several lines of code. So in our app, we have like a chatty controllers folder. We'll want to create a chatty channels directory. And then we'll make a rooms channel. Oops. And then we use phoenix.channel. And we're going to do one more thing. So all channels are required to define a join function. And this is going to basically serve as your authorization for joining a particular channel. So if you don't define this, it's going to crash. And you have to basically abide by a very restricted level of conventions here. So there's only 2 return types that this can return. And this is going to serve as your authentication layer. So when you're joining, you get past a socket that's going to be multiplexed. And then you're joining not only a channel, but you're joining a channel and a topic. And this has confused a lot of people, so hopefully I'll be able to describe the channel and topics and what those mean. So for now, we can just think the topic can be anything. And then when you join a channel, the browser can pass up any kind of additional authentication data and some kind of message. But for now, all that the join needs to do is return OK socket. So if the socket is authenticated, its only job in life is to either return OK socket, or it can return error socket and then reason if they were not authenticated. So we can say like unauthorized. So those are the only two return types, but for now, we're not worrying about authorization. There's no database layer. We're just going to have a global chat room. So for now, we just return OK socket and everybody's happy. But you could have returned something like, defined a authorized function, pass in the topic. Maybe the topic was like a SHOD version of some database room for your company. Maybe there's a rooms table in your database and a room ID concatenated with some room key, and that's what the topic is. And then the browser client could have passed in some kind of topic up to be authenticated with, but we're not worrying about authorization at this point. So we're saying everyone can join, and that's that for now. So that's our channel at the moment. And we need to write a little bit of JavaScript to actually have this do something now. So in our HTML file, I'm just going to write the JavaScript directly in here because that's how everyone does it, right? No, it's it's just a little simpler here, and it actually allows me to show you how simple it is to write a real-time app in Phoenix. So if you're shipping this in production, you should probably write JavaScript outside of index.html, but for now, it's the easiest thing for us to do. So the first thing we want to do is say on doc ready, we're using jQuery here. We're going to create a Phoenix socket. So I can say var socket equals new phoenix.socket, and this is that Phoenix.js dependency that you saw earlier. So we're going to connect at that endpoint that we defined earlier. So say whatever the current window location host is, and then we mounted it at /ws. So that's what this represents. And this is going to create a multiplexed WebSocket connection for us, and Phoenix is going to handle all of that and reconnecting on failure. It actually will continue to try to reconnect till the end of time. So it's kind of fun that I can shut the server down, and if I leave a browser tab open and I fire my app back up, I get a bunch of connect events because it's just trying forever. So now that we have a socket, we should be able to try to join a channel. So I can say socket join and give it a channel name. So we had a rooms channel in our router, and then I give it the topic I want to join on. And the topic concept has confused a lot of people, so hopefully I can clear that up here. So you can think of channels like controllers. So they're just a place to group behavior, application behavior, and then a topic is almost like a resource. So if I had like a HTTP controller and I had like a rooms controller that I posted and to get requests to, I would have some room ID, and that would be the topic. So usually the topic's going to represent some kind of resource. It could be an ID, it could be a token, it could be anything. But in our case, we have a global chat room, so it's not really scoped to a database record. So I'm just going to call it a lobby. So if we're building like a chat app, we can say that you could have a lot of private chat rooms for like a bunch of companies, maybe a bunch of organizations have team members that can subscribe to like a general topic on a particular company ID. But for our case, we just have a global chat room that everyone can subscribe to. So we end up with a nice like tragedy of the commons scenario with a global chat room. But in our case, we give it the channel name, topic, and then we can pass up any kind of authorization data that's required. I'm just going to pass an empty JavaScript object because we don't care about any authorization in this case. And this is what's going to call that join event on the channel. So then the callback we get passed is a connection to that channel. Or I'm sorry, callback we get passed, it just is literally a channel. So if I do nothing else here, we should at least be able to see the join events come into the server. If I go back to our rooms, I'm just going to put a little bit of debug data here. We're going to say the socket tried to join, socket.channel, and then the topic. So we should at least be able to get here and have it not crash. Refresh this page. it works. We got a join event, trying to join the rooms channel. The topic was lobby. So WebSocket connection is currently connected to that channel. It's active, and it will keep reconnecting on failure. So what I like to do here, if I have a hard-coded channel like lobby, I'll just hard-code it here. So we can say anyone that tries to join, hard-coded topic. Anyone tries to join the lobby channel, we just return OK socket because we know that it's public. Everyone can subscribe to it. And then that would let you later say, okay, we added a database. We have companies with private chat rooms now, and you could pass up some kind of private topic. Could be anything. So beyond the scope of this, so for now, our implementation is just going to be, if you try to join any other topic for now, we're going to say you're unauthorized. Okay, so we have a WebSocket connection. We need to actually send some events. So back in our JavaScript, someone asked a question, David. I heard a noise. I don't know if someone posted a question or whatnot.
No, I think that was just taking a capture.
Okay. Okay, so we actually want to send some events on this channel. So we create a WebSocket connection. It's not very exciting. Let's actually do something with it. So we can say if we hit this callback, you've joined successfully. Let's send an event out. So before returning OK socket in the controller, I can say, okay, broadcast to anyone currently listening on this multiplexed socket and channel. We want to broadcast the event, maybe user entered. So someone entered the chat room, and the content of our message is going to be anything we want. So I can say maybe the username was whatever the username they passed up in their message. And if they didn't give us one, let's just say that their username is anonymous for now. So, and then back in my JavaScript layer, I could say, okay, I have this channel. I'm going to say chan.on an event, user entered. I get passed some kind of message from that channel. And then I can say, maybe I have some jQuery object messages, .append. Trying to stay basic right now, so I'll use some nice BR tags. So maybe message username entered. So maybe log to the channel that someone entered whatever that username was they passed up. So theoretically, I have to also define that container. So I could say var messages is going to be equal to, I have a div ID messages here. That's just the main chat message list. So theoretically, this should work. Okay, well, good. I'm showing off the Phoenix gives you nice error messages. So something blew up, and I get a formatted error page currently. So that's handy. Let's see what happened. Oh, I'm using the variable topic here, but it was hard-coded as lobby, so that's why I failed. Okay, so it's actually good this popped up. So Phoenix has code reloading, but sometimes it's a little bit touchy. So if you ever see an error that you can't define or a module because it's currently being defined, I apologize. You have to restart your web server and restart it. I'm basically recompiling. I'm running a mixed compile in process to reload the code. It's pretty naive. It works like 90% of the time. Sometimes it doesn't. So until we have a better way, I'm trying to fight my battles right now currently. So that should work. So now we notice nothing happened here, but if I load up a different browser tab and go back here, I get anonymous entered. So that actually works. So as many tabs as I open here, actually I'll just refresh this one. So if I refresh the browser, every time it connects, it's going to rejoin the channel and it's going to broadcast out that someone has entered. So if I go back to my active original tab, I see a bunch of anon-entered flags here. So now I'm going to open up my port locally and see if everyone can connect. Just so as we build this, we can share what's going on. Let's see if this works. there's a global chat in the Hangouts, right? Okay, I just pasted a link into my infinite recursed background here. I should see a bunch of people enter. Hey, there's one. Maybe. Okay, so it is working, I think. Awesome, cool. Okay, so we can see everyone's currently joining. You're tunneling to my local server that I'm currently writing, so don't do nefarious things to my computer. I don't know what forward opens up. So let's actually make this a chat app. So now we have events that we can post. JavaScript side can receive and send events. Let's add a little bit of real behavior. So to do that on our JavaScript side, we need to be able to post messages. So we can just say, use a little bit of jQuery. And what are we going to do here? Okay, we're going to say that I have a couple inputs here. So I have a message input and a username input. So I'm just going to create those as jQuery objects quickly. Username input. Okay, so create a couple of jQuery objects, and then I can bind to an event. So if you type username input on, so first I'm going to unbind key press. So every time the WebSocket connection drops due to connection issues or for any reason, it's going to refire this join callback. So any binding we do in here, we want to make sure that we reset it. Okay. So we can say if anyone remember what enter is? 13? Anyone key code for enter? 13, I think so. So if you type the key press where it's enter, we actually want to send a message on the channel. So we can say, we want to say, if you hit enter, let's say chan.send. So we had chan.on, we could say chan.send to send a message. On subscribes to an event. So we want to send an event saying, maybe we're going to call it a new message. And then we can give some JSON to say, here's some the actual payload. So maybe we're going to say the content of the message is message input .value, so whatever you typed in. And I need to use brackets here. I'm used to writing CoffeeScript. So we're going to send up a content and then also the username of the person that sent the message. And that's going to be the username input value. Okay, and the last thing, we probably want to clear the message input so you don't have to backspace it yourself. It's a miracle if all this JavaScript's correct the first time, because I don't write vanilla JavaScript very often. So we've sent the new message event here. We actually need to handle it. It's not going to do much. It's going to ignore it if we send this message up. So we actually have to handle it on the Phoenix channel side. So back on our Phoenix channel, in addition to my join events, I can define event functions. So we can say when we get an event for a new message, and this is arbitrary, whatever you want to pattern match on for a particular socket, and it passed up as a particular message payload. And I'm thinking I will probably switch around these two arguments here. So if you pull Phoenix down tomorrow and it errors out, it's probably going to end up being socket as a first argument always. Only because that's where I use socket as a first argument everywhere else. So just a heads up. So if any client sends us a new message event, we don't have any database layer. All we need to do is a simple thing and say we want to rebroadcast that message to everyone connected. So I can broadcast out the event new message. I'm just going to forward it to all active clients. And I can just pass the message in here directly. I'll be a little bit more explicit though instead, and I'll say that the content is message content that they passed up. And the username was whatever they told us it was. Message username. And then the important thing to not forget is we have to return our socket from the event. If you forget this, it's going to crash and you'll get like a really nasty error message. I'm going to try to improve that a little bit. But since Elixir is immutable, we could change the socket state. We might unsubscribe a user. We might add some other subscription to this socket. We could end up, there's a way to store state within the socket. So we can be storing basically ephemeral state on our multiplex connections while the socket is alive. So we always have to return the socket from each event. If you don't, it's going to die, and I'll try to improve the error messages. So that's just something to remember. So basically, all of our new message event does is say we're going to broadcast back out to anyone currently connected that same event message. And that lets us go back on the client and just define another event saying, okay, anyone that receives a new message, let's do something with it. So on the new message event, we're going to have some message payload. And again, we're just going to do a really quick and dirty append of a message. So we know that that message is going to have a username like before, but instead of saying entered, let's just append the message content. This might be off the screen. Oh, it works. So theoretically, we should have a chat app if everyone refreshes, maybe. Enter your username. Hello. And nothing. It's forked. Let's see what happened. No JavaScript error. Did we crash? No. Oh, my key press should have been for the message input, not the username input. Derp. Let's try this again. So if anyone is still connected to that forward URL, we should actually have a working chat app right now. I don't know if anyone can. You have to refresh your browser though, because all the code changed. So we'll see. Maybe. Did I kill? I might have to restart forward. Oh, I have to forward crashed, or maybe because I killed the server. All right, give it another shot here. So forward is running. Oh, the URL.
URL in there, Chris?
Yeah, the URL changed. Sorry about that. All right, new URL. Let's try this one more time. That work? That worked, David?
Yeah, it's okay.
And then you should be able to enter a username and a message, and we should have a working chat app. There is no cross-site scripting sanitization, so don't push JavaScripts. So this is a Elixir chat app. So it only took a few lines of code. Our JavaScript, outside of the curly brace indentation, if we were writing CoffeeScript, this would all fit on a single my single screen here. So it's a very basic API. We can join rooms and broadcast on them. We can send events. But the neat thing is that we can do all of this outside of the web request or the socket request. So if I have browsers up and running, if you leave your browsers up and running, I'm going to fire up an IEX session here. But I'm actually going to have to kill my server again. So the URL is going to likely change again. Let me try this. Oops. Yeah, forward died. So I'm going to have to generate another link. This will be the last time we have to do this because I wanted to start up an IEX session and could have connected another node and had it work, but I didn't start up a named Elixir node there. So new link, dfy.chrism instead of qgc. And if you get some people hopping in there, we'll do the next last bit of magic here. So now I have an IEX session up and running of the app. I'm going to get a bunch of log data here, which is actually going to be problematic. I should have started a node here. I could. Yeah, I'm gonna do that. I'll wait. Oh my gosh. We'll wait till everyone joins because I'm not gonna be able to type here and not refresh. But basically, I can push a broadcast directly from IEX if I can end up typing here. I'm going to alias Phoenix channel. I have a bunch of connections that keep dropping. So basically, I can say channel broadcast, but I have a bunch of debug data. Oh, I have live code reloading. I can stop this. We can make it better. All right, I'm going to delete that IO puts because it's making me not be able to type. I should get code reloading when I refresh here. See what happens. Okay. Now I can type.
You lost the rest of us. Oh, never mind.
Yeah, I think everyone is going to reconnect because the server had to restart. But I'm still logging GET requests, which is a problem. That's all right. I'll just type. So basically, I can say Phoenix channel broadcast, and I have to give it the fully qualified channel and topic. So I can say, let's broadcast to the rooms channel lobby topic, and I give it some kind of keywordless payload. So like I said, the content is going to be, what's the new line here? Phoenix from IEX. The username is going to be IEX, and this should error out. Oh, I have to give it an event. So I gave it the rooms channel lobby topic, but I need to broadcast on a particular event. So the event is going to be new message, just like our controller or our channel. Content Phoenix from IEX, username IEX. And we should have gotten, yeah, everyone should see that in their browser. So basically, we're not limited to Phoenix channels and handling just WebSocket connections. We could have this running in any node on any part of our cluster, and we could be pushing out updates to the browser or any other listening WebSocket connection. So my goal is this. My goal for Phoenix isn't just to be just like a standard web application framework. You should be able to do all kinds of stuff. You could have some kind of node running a particular like analytics service, and this thing could be pushing data to any active channel and topic from anywhere, which is kind of neat. Push another really excited message. So that's basically building a chat app in Phoenix. That's where I'm at with it currently, but I think the current implementation is good to go. I encourage everyone to check it out and play with it. I plan to try to build some kind of conventions on top of it, or maybe pushing rendered partials down and doing some other neat things. So we got a little bit of time. The other thing I wanted to talk about was how we implemented the topic server and doing failover for the topics, because I'm not an expert in OTP yet. So I'd like to get, if anyone's familiar with doing globally registered processes, please chime in or chime in later. But I'll go into that momentarily. So we're going to go into the Phoenix master repo. I'll open this up. So this is just the Phoenix code base, and I'm going to just throw in a couple debug statements to show you what's going on here. But basically, I have someone raise an issue earlier with the initial topic implementation where there was a race condition, and if a node failed on the cluster, we could end up with a bunch of ghost topics that were never cleaned up. So if we had a lobby topic, if you imagine if we had a topic per room in our chat application, we could have hundreds of thousands of companies. They could also, each company could have dozens of actual chat rooms. So we could have millions of these topics hanging out there waiting for connections. So we want to clean these up. If there are no active WebSockets for a given topic, maybe everyone's logged off, we want to go ahead and clean that up out of the process pool. So we have that implemented in place, and it currently does failover as well as race condition protection. And the way it does that is I'm using a topic supervisor. So every Phoenix node that you start up starts up a topic supervisor. And each of those is going to start up a topic server, but there can only ever be a single global topic server on the cluster. So the global topic server is just a gen server. On its init, it's going to basically have all nodes compete to register their server as under the global registry. So only one person can win. Erlang will enforce you can only register a single PID to a name on the cluster. So only one person can possibly win. If they win, they're going to go ahead and start the garbage collection check and start their role as leader. If they lose, they're going to link to whoever the current leader is. They're going to do a process link and then start as slave. And what this gives us is if that node goes down that was the active leader, since we've linked here, it's going to crash our slave processes. All those slave nodes are going to restart, and it's going to be recalled, and then the global competition restarts, and only one person can win that. And whoever wins that, everyone else links to their process, and so on, and this thing basically continues on forever, always failing over, recompeting for the global registry, and whoever wins serves as that topic server. And the reason why we only have one currently is we want to broker all WebSocket connections and topic join, create, and garbage collection events. We want to make that synchronous. So we're creating an intentional bottleneck from all these concurrent nodes running, because we don't want someone to have their topic like lobby garbage collected out from underneath them, because the garbage collector is going to say, is anyone actively listening? It's going to get no back, but after it gets no back, before it calls delete, there could be another node that actually had registered lobby out from under them. They could then have their topic deleted. So by forcing this all into a bottleneck through a gen servers always process only one request at a time. So we're basically forcing an intentional bottleneck to broker all topic connections and garbage collection. And if the node dies, it's basically going to restart all garbage collection events. So that's essentially the approach I took. I'm going to spin up a bunch of topics to show you how it actually works. Right. Go into my topic server. I have a randomized time that the topics have to be garbage collected, because if a node fails, it's going to go through every single Phoenix topic, maybe 1 million, and restart a bunch of garbage collection timers for sets of like a couple hundred at a time. And if we had those all timers fire at the same time, we'll end up like denial of servicing attacking our gen server, because all those topics restart at the same time. So I give it a range. It doesn't have to be exact, because we just eventually want to check on these things every so often. So right now it's like 1 to 5 minutes. I'm going to lower that to show you how it works though. So let's say 10 seconds to 20 seconds for now is good enough. That should work. We can say whoever fails to register as leader, we're going to say starting as slave. Whoever won gets to start as leader. All right, so now I'm going to fire up a couple nodes in Phoenix. Let's say IEX. Really secure password there, and start it with mix. So now I have this node running, and we can see that it started as leader. So we have a leader, globally registered topic server. And if I start up a second node, name it node 2, it started as leader as well, because they're not connected yet. So we have them both running on their own Elixir nodes as leader. What happens if we connect them together? You can say in one, connected, and we can see immediately it crashed and started as slave. If we go back to our first node, we can see that Erlang detected that there was a global name conflict, and it killed one of them. But since it's supervised, it restarted and it just said, oops, I lost the global name race, now I'm slave. I do nothing but link to the other node to monitor in case it dies. So on the first node, we can spin up, we'll manually spin up like 10,000 topics. So if I ask Phoenix, how many, tell me all your topics, we can see there's no topics because nothing's happening. So if I do like a enum each, maybe 1 to 20,000, I'm going to create 20,000 topics. So Phoenix topic create is being called under the hood under Phoenix channels. It's abstracting all this from you. So just to show you what's going on, we'll create topic I. So we're going to create 20,000 topics. And these topics, eventually, we want these to be garbage collected if we don't have any subscribing processes, because there's no reason for them to live. We don't want them to fill up memory eventually. I think that should be it. So that's going to create 20,000 topics and also start timers to garbage collect them. And if we hop back to our other node, we can see that this thing should be able to look up all the active topics. And there should be a bunch of them. So now there are 20,000 topics running, and they should all start to be garbage collected between 10 and 20 seconds from now. See, they're all counting down. I waited too long, so they're going to be, okay, so we don't have any topics left because no one was subscribing. So I'm going to restart 20,000 again and show you the failover. So the current node, this is N1 that we're looking at. This is the one that's brokering all create, join, leave, and garbage collection events. So we have 20,000 topics created. If I check on this node, there they are. So if I kill this node, N1 just dropped down. We can see that node 2 actually just restarted as leader, and it should continue garbage collecting. And there it goes. So these topics are going to start counting down. So node 2 just took over as leader after node 1 died, and we just started garbage collecting all of the topics that don't have any subscribers. So there's how I'm handling node failover and garbage collection, fault tolerance, the whole shebang. I'd love to have feedback on the approach. I think it should work really well. Like I said, it's a forced bottleneck, but I think that's the way these things make sense. We have to make things synchronous where possible, and using a gen server, a single gen server globally registered for this, for me, seems to work perfectly. You notice we had 153 topics that didn't get cleaned up. It's because we're buffering these. We're not creating 20,000 timers. We're buffering them up in sets of several hundred, so we're not creating a bunch of unnecessary timers. So yeah, so that's the Phoenix real-time WebSocket layer. I don't know if we have any questions or whatnot, but hopefully that gives you a little bit of magic on where I want to go with this.
If anybody does have questions, feel free to drop it in the, I guess the easiest way is to drop it in the chat. You can find that over in the left-hand bar.
This could get dangerous.
Well done. Yeah. In the left-hand bar for Google+, there's a chat little thing over there. It's the top button that slides out. Just drop your questions over there. I do have a quick question.
Yeah.
And Chris, I can repeat those so you don't get the crazy view. Is this in master now?
Yes, as of this morning.
As of this morning, sweet. So bleeding edge.
Yeah, so and this is all, so Phoenix is on Hex now. So I should mention anyone that's not on using their, if you're writing an open source Elixir project, you should put it on Hex. Hex is the package manager, does dependency version resolution and everything. It just shipped like a couple weeks ago, so get your project on Hex. All of Phoenix's dependencies other than Cowboy are now on Hex, which is nice. So basically get on Hex if you're not on there yet, and you can use Phoenix in Hex. If you open up that Bootstrap project, you go to that mix file. With Hex, it's as simple as adding your Phoenix dependency as just the atom Phoenix and then the version. And Hex is going to manage that install for you, which is super nice. But yeah, this is in master now, and this is all on Phoenix 0.22. Latest and greatest.
For those who joined late, there's a handful of conferences coming up. If you have one, that you want me to mention right now, feel free to drop in the chat and I'll do what I can. Chris is going to be at Elixir Conf in June, was it, or July?
July.
July. So in July, Elixir Conf down in Austin, somewhere down in Texas.
Austin.
Austin is Elixir Conf. He's going to be talking about Phoenix and where that's going, and said hopefully we'll see a view framework or a view layer at that time. I will be up in Michigan, Detroit, Michigan, at the end of this month, doing a quickie 1-hour session on getting up and started with Elixir, as well as in August I'll be out in Wisconsin at that conference. It's called that conference, funny name, and then also James Smith, who's on this session right now. He is going to be at ElixirConf as well, talking about building command line tools with Elixir. So I think there's a lot of cool stuff coming up this year. It's going to be fun. If anybody else has anything they want to share, feel free to either do it in the Google Hangout or the Google event. I've also dropped in both the chat as well as the Google Plus event RSVP for June. We don't have a topic yet, but when if you have one, let me know. Either ping me on Twitter or something like that. I'm at Cromwell Ryan, or let Chris know, and we'll figure something out. Even if it's short, if you have like a 15-minute topic you want to talk about, we might be doing. We're doing a bunch of other meetups with lightning talks this month, so we can also do a Dayton Elixir one as lightning talks. Hopefully this will be recorded. Google Plus has been, for public hangouts, have been good about recording these things.
Yeah, I'm running ScreenFlow locally, so this would be up on YouTube in nice quality
afterwards. It's not
afterwards.
automatically on YouTube because of the public hangout, which it was last time. It'll also be, Chris can also publish it out there, so this will definitely be available. So we'll put it out there. And with that, I think it's it. You have anything else? Oh, Richard said he's going to be talking about the growing adoption of the language and learning Elixir. So
Awesome.
Be sure to get tickets to ElixirConf in Austin. It's going to be good.
Awesome. All right. Well, thanks everybody, and thanks Ryan for hosting.
Yeah, thanks everybody. Talk to you later, guys.
Yep.
Yep, thanks everybody.